Okay, hello my friend. This is the lab session number 3 for CMP 325. Actually, this is your lab sheet. I know here we write the CMP 324, but it's the same as your. In previous semester, this course name was the CMP 324. Now we change it to the CMP 325. Your course, so it's your lab sheet actually. The lab session number 3. In this lab session, we are going to talk about the LW and SW for load and save in your register and in your memory. Actually, at first, I'm going to tell you something about some features, some point of the MIPS assembly language. In high-level programming language, if you remember, you can define, for example, different variable x, y, z. You can define million and 100 or 1000 or 1 million variable. You can define many array or something like this, and you are not supposed to be careful about the number of the variable or something like this. But in the MIPS language, when you are going to use the register, it's something different because you have a limitation in the register. You have a limited number of register. For example, you have a 32 register for your integer number, or for your float point number you have a 32 per register. Actually, you can see the register number begin from this 0 to 31. So we have a 32 register for the integer and also for the float number. So it can be very bad things at first when you're looking at this number of the registers, and okay, 32 is not enough for our big program. Okay, but actually, why the MIPS like this? Actually, maybe you think that okay, the MIPS can define more register, can define 1000 register, can define, for example, 1 million register. Yes, but this is the problem. The problem is that if you define more register, it means that you have a more delay. Actually, the speed of the register is very high. So that's why if you have the limited number of the register, your speed will be fine. That's why actually we have a limited register in the MIPS, because we need a higher speed in the reading and writing of the register, and also a higher number of the register or gate or something like this erase our delay. That's why we don't like it. It can be because of the higher delays, and we don't like the higher delay in our hardware. And another point, actually this is your lab sheet. I'm just trying to show you some important point of this lab sheet. The another thing is that our processor or our CPU actually have only the restricted number of the register, limited number of the register for the saving the data, and but don't worry, we find a solution for this one. Actually, we know that we have a memory in our hardware. Okay, so instead of the CPU, we can use the memory. We can load and save our data to memory and to the register. So for example, we don't need to save everything in the register. We can save everything in the memory, and whenever we need some information, we need some data, we just load it from the memory and to the register, and we use it. And also at the opposite side, we can when our job is finished with some data, we can save it again to the memory, so we don't need to save the information, the data in the register forever. So we can just bring something from the memory to the register, do our procedure on that data, and after, when our job is finished, again we send back that data to the memory again. So for this transition, bringing from the memory and save it to the memory, we use two transfer actual function, LW and SW. Okay, at first let me talk about the LW, load. Okay, load word. Okay, load word, LW.